Kathy and Jeff back again. This time we're here to visit Grade 3, Unit 4, which is magnets.
You know, Kathy, magnets are like people. Some are attractive, others are repulsive.
Very funny, Jeff. So we'll get into that a little bit later. So magnets are important. They're all around us. Did you know that there are magnets in cell phones, televisions, cameras, washers and dryers, elevators, barcode scanners, your refrigerator, and even the MRI machines that doctors use to look inside people's bodies?
That's amazing. I didn't know that, but I do know some things about magnets, such as this is a magnet, and this is a magnet, and these are magnets. I also know that magnets can pick up some things that are made of metal, but not all metal. They can pick up iron, nickel, and cobalt, but they can't pick up metals like silver or gold.
Okay, so I do know that iron's a very common mineral, but here's an interesting fact. Did you know that we live on a giant magnet? The center of the Earth is mostly made of iron and nickel.
Cool, but how do magnets work?
Well, Jeff, I'm glad you asked that. So all magnets have two ends that are called the poles. There's a north-seeking pole with the letter N and a south-seeking pole with the letter S. So to see how magnets work, let's take a look at these two bar magnets. And Jeff, I want you to take the two magnets and put the two letter N's or the north poles together. What happens?
They push apart.
All right, so that's right. The same poles will repel or push away from each other. Now try putting the letter S next to the letter N. So the south pole is connecting to the north pole. Now what happens?
They pull together.
That's right. So in this case, they attract.
Hey, what if a magnet was cut in half? Would we end up with one magnet with both ends north and another with both ends that are south-seeking?
Well, that's actually a really good question. The answer is no. What you would end up with is two smaller magnets, each one having its own north and south pole. So I think it's time we look at an activity for this unit.
Great. For our activity for this lesson, we're going to be following the 5E model. For our first E, I've got a poem to engage our students.
Of course you do.
It goes like this. Magnets attract, that's a fact. Things like nails and metallic pails. Magnets attract, that's a fact. Things like cars and lids on jars. Magnets attract, that's a fact. Things like pins and cookie tins. Magnets attract, that's a fact.
So thank you for that poem, Jeff.
Sure.
All right, so for the first part of our Explore, student partners will get a magnet and a sorting chart. They will go on a classroom or a school-wide scavenger hunt where they're going to hold the magnet to different objects in the classroom to decide if the items stick or attracted to each other or if they're not. They will write down the items that they checked and then place that item under the category either magnetic, non-magnetic, or both. Then students will come back and meet with another learning team to compare their list. So here would be a good opportunity for some science talk, which will lead to a better understanding of how magnets work.
We're ready for our next E, Explain. Here we might read a bit of our textbook, which would be Chapter 13, Lesson 2. Or you could read one of the level readers, Electricity and Magnets, or Invisible Pull, Electricity and Magnets. Or perhaps someone in your school has the book, What Makes a Magnet by Frank Bramley. For our Extend, students will complete the investigation in the HSP textbook on pages 534 to 535. Which magnet is stronger? For this, they'll get a bar magnet and a horseshoe magnet. They'll also get 20 paper clips. They'll hold the bar magnet near a paper clip and record what happens. Then they'll do the same thing with a horseshoe magnet. Next, they'll pick up as many paper clips as they can on one end of the bar magnet and record. Lastly, they'll pick up as many paper clips on one end of the horseshoe magnet and record the data. They'll complete a data table with their information.
Okay, so using that data table, the students will be able to determine which magnet is the strongest. So you want to encourage them to make a claim supported by the evidence or the data that they collected. Bringing the math in, students could communicate the data on a bar graph to show how many paper clips each magnet held. So in terms of 5E, our final E, evaluate.
So teachers, this is where you can get creative. How would you evaluate this standard?
So let's take a look at resources on the Moodle site. When we get into the Science and Engineering Grade 3, we're going to scroll all the way down to Unit 4, which is our unit on magnetism. When we get to the unit on magnetism, you'll see the duration for this unit is 2 weeks. There are your big ideas, your essential questions, and the unit planning guide. So when you click on this, it will download the curriculum map for you. The curriculum map will give you the standards associated with this unit. In this case, we're going to conduct an investigation to determine the nature of forces between two magnets based on their orientations and distance relative to each other. This is where the kids are going to learn about the North and the South Pole, how magnets attract and repel. The next part, define a simple design problem that can be solved by applying the use of the interactions between magnets. This would be something like examples of problems including constructing a latch to keep a door shut, creating a device to keep two moving objects from touching each other. We're keeping it simple at the 3rd grade level, but trying to get kids to understand that magnetism and understanding magnets has a purpose in real life. When we scroll down, you'll see your big ideas and essential questions. The knowledge, what should students know? The skills, what should they be skilled at? And our tier 1, 2, and 3 vocabulary. So let's go back to the unit. There are some great resources here. This document, Magnets, a 3rd grade curriculum, when I click on that, it opens up a whole series of lessons. There are some assessments. Definitely a great resource for you to look at as you're planning your unit. Next, we have a PDF, Basic Magnetism. Again, some more lessons and activities. We have the HSP leveled reader, Electricity and Magnets, and the other leveled reader is Invisible Pull. You can just click on those. They're PDFs. They would download. You can show to students on the computer. Click on this link here for 25 more websites for teaching magnetism in elementary science. Look at this last resource, Discovery Ed Magnets Videos. If I click on this link, it will bring me to a place where I need to log in to Discovery Ed. Don't forget, your username is your 10-digit phone number, and the password, if you've never logged in before, is the word discovery. So then you're going to click log in. It will bring you directly to this site, which is a collection of videos for magnetism. Up here in the search bar, I just typed in the word magnetism. I filtered by grade 3 to 5, and you can see that there are a lot of videos here for you to choose from. Some of them are just video segments, but they will all lead you back to a full-length video if you're interested. You can click on the tab to load more and just keep looking for that just right video for your classroom. Don't forget, many of the videos are available in Spanish, and also if you click on some of the videos, it will give you additional related materials such as a teacher's guide. So make use of the Discovery Ed videos. Have fun with your students as you do this unit on magnetism. We know that they really enjoy this topic, and we will see you for our next unit, which is Unit 5, Weather Prediction and Design Solutions, in just a couple of weeks.
We hope that you were attracted by today's activities because you know, science matters.